My full name is Alan Edward Guttmacher, and I'm the director of the Eunice Shriver National Institute of Child Health and Human Development here at the NIH. I was born in Baltimore at Johns Hopkins Hospital on November the 24th, 1949, about 6:30 in the morning.
How did your life experience after finishing Harvard influence your later life and career?
I think, I've spent time in my life where my best friend was a guy, arguably my best friend was a guy who worked on a garbage truck. And I spent time after, graduating from Harvard College working on a loading dock. So I think I've had a less rarefied life experience than I would have had otherwise. And I do think, certainly when I practiced medicine, that was of help. But I think I think part of what I've brought to the NIH is I'm not in some ways the typical NIH employee in terms of past focus on research, which I did research, but it was not my focus in life. But I think also I've lived a fairly broad life, and that's informed the way I prioritize or value things, I suspect.
How did that experience influence your work at NHGRI?
Arguably, my contribution here to NHGRI was when I came, first of all, the only other MD except for intramural was Francis. And second of all, my perspective was not that of a researcher. It was of a clinician primarily. And so I was really most interested in the question of, great that you sequenced the genome. That's very neat. Glad you did it. But what are we going to do with it? And I think, again, when I thought about that, I thought about people's lives, not just how is somebody in a lab going to use it, but how are we going to use it in medicine, and how are people as patients, as whatever, going to use it in their lives. So I think that was useful background.
What brought you to pediatrics?
Certainly, the one that I can draw the most direct line, perhaps, is clearly part of what drove me to pediatrics was when I was teaching middle school. And I had 3 students who were labeled as quote unquote dyslexic. And I read the educational literature about that, which seemed, so this was in the early 70s, and the educational literature about dyslexia seemed to be all fluff and nothing there. I read some of the pediatric literature to the degree that I could without a scientific background. And it seemed much more scientific. It seemed much more rigorous. So that's a large part of what drove me into medicine. It wasn't the only thing, but certainly what drove me into pediatrics eventually was the idea, gee, I'd like to try to figure out this thing about learning disorders. What's the biology of that?
Why did you go to medical school?
I was a little bit frustrated in teaching in that I was teaching in a private school. And I felt that what I was adding to kids' lives, these were kids that didn't need much added to their lives. And looking at public school teaching in those days, which was my other alternative to stay in the field, was really, from what I knew of friends that were doing it and the little bit I've observed of public schools, was being a traffic cop. And I didn't really want to do that. I wanted to do something where I thought it could make a contribution to people's lives. And that was the first ideation of public health. And then a brother who was in medical school spoke to me and convinced me. I come from I should have mentioned but a varied line of physicians in my family. So he basically said, give up this post-adolescent rebellion, throw in the towel and go into the family business. You actually, if you want to get an MPH, you can always do that later. But having the clinical background and skills would be useful. Why don't you do that? It seemed like a pretty reasonable argument. Now, there were all these pre-med requirements that I had to do, and did I want to take a year and a half out of my life to do that? But I thought that would be worthwhile. So it was really the idea that I wanted to do something, and I'd seen this in my own family, where I could do something that would be intellectually rewarding, but most of all, that I thought I could make a difference in people's lives.
What did you enjoy most about medical school?
I loved everything. I did very well. I enjoyed my challenge, as it is for a lot of medical students, was to figure out which of the various kinds of fields I might go into, because they all seemed like so much fun. and decided on pediatrics, both because I continued to have this interest in children's learning and other aspects of child development. Also, I think the conviction that if you could change the arc of a kid's health and well-being, that there was lifelong impact of that. And I enjoyed dealing both with kids and adults. And I thought that if I did pediatrics, I'd be able to deal with both because kids usually come with parents. And that I like being involved in those kinds of things too. And I've also developed a real interest in birth defects. And so part of it was, and that was really the tie to the genetics, was through birth defects, was, gee, wouldn't it be interesting over the decades of my career to play some role in helping figure out what causes birth defects? Can we do anything to prevent them, kind of thing?
Describe your early training as a medical geneticist.
So I did, after my pediatrics residency, I did a medical genetics fellowship for a couple of years in Boston at Children's and at Harvard. And I was going to combine primary care pediatrics, which had really been my love for a number of years. I was going to combine that with medical genetics. And originally was going to stay in Boston doing primary care pediatrics 3 to 4 days a week and doing medical genetics 1 to 2 days a week, but somewhat for financial reasons and wanted to get to Northern New England if I could. Ended up taking a position at the University of Vermont doing primarily medical genetics, a little bit of not primary care, but some more general pediatrics on the side. But really doing medical genetics. And when I got to Vermont, part of what drew me about that position was that I was taken on the role of being the only medical geneticist in the state of Vermont. So you were given to some degree the responsibility of figuring out what made sense for the entire state as a kind of public health kind of genetics role. So besides seeing lots of patients, doing a lot of teaching, a little bit of research, it was trying to figure out how do you use genetics in healthcare in Vermont quite broadly. Part of that was looking around. Vermont did not have a state newborn screening program when I got there. There was a hospital, the Medical Center Hospital in Vermont, which was the hospital out of which I was based, really, part of the University of Vermont, that performed the assay. And I think it was 8 birthing hospitals approximately. There aren't very many birthing hospitals in Vermont. There weren't, and there still aren't. Sent their specimens there, but there wasn't really a state program. There was no really coordinated follow-up of the kids, et cetera, et cetera. So I, having come from a training in Boston where I'd been exposed to a more organized statewide screening program, started saying, well, gee, don't you think we ought to try to do that in Vermont? And everyone sort of readily agreed. So we started a newborn screening program, and I was the medical director of it as we started it, and which meant both we did all the newborn filter cards, came through my office. I had several years for quite a while stored on top of a shelf in my office of the old filter cards. All the debate these days about ownership, et cetera, seems that was an, let's say, antiquated situation.
Why is screening for the genetic disorder PKU important?
I can give you both a scientific and a kind of visceral answer to why PKU is important. So PKU, or phenylketonuria, refers to kids or adults who lack a specific enzyme, or at least lack full enzymatic activity, and can't digest an amino acid that's found very widely in the food that we all eat. So the treatment for PKU is sort of twofold. One is to limit the intake of most protein, but also, because protein is important to life, giving back all of the makeup of protein except for this one that the kids can't metabolize correctly, so they can still have healthy lives. What PKU was really first described, I think, in the 1930s, but first mass screening for it in the 1960s, developed by a guy named Bob Guthrie, originally in Buffalo. And the idea of this was you could do very easy and expensive screening at birth. And the reason for doing it at birth is that kids who have PKU aren't symptomatic for a long time. left untreated. But by the time they are symptomatic, there's already been enough damage to the brain and central nervous system that to some degree it's irretrievable. And in terms of not the science, but just what does this mean? I can remember when I was at the University of Vermont, part of my clinical coverage was for upstate New York, seeing a woman in her 40s, I think it was, who was still institutionalized even though in an era when most folks with intellectual disabilities were being put in community settings, et cetera. This was a woman who was still institutionalized in the state facility in New York who had PKU, but it had not been picked up until she was in her 20s. And it's hard to say exactly her functional level. It depends on what part of her life one described, but probably was more or less equivalent to a 1-year-old, I would guess. And so that, besides the book learning about it, seeing what happened if you didn't notice this, if you didn't make the difficult to live with, but not impossible changes to diet that can happen. That's why PKU, first because the first one really understood, but why it has become kind of the symbol of so-called inborn errors of metabolism that can be picked up on testing in the newborn period.
What did coming to NHGRI make clear to you career-wise?
Only in retrospect, when I came to NHGRI as a senior clinical advisor to the director, did in fact my career make any kind of sense to me. Because then, I'd run a newborn screening program. I had seen lots of kids with genetic problems. I'd been the PI for a LC, an ethical, legal, and social implications of genetics supported program, statewide conversation about the ethical implications of genetics. So I had done a bunch of different things which sort of didn't hang together, except they hung together very well as being preparation for being at NHGRI to start thinking about, well, how are we going to use the sequence to actually have an impact on people's lives?
How did you come to the NHGRI as senior clinical advisor to the director?
I went to a meeting in Santa Fe, New Mexico, that was held by a group called the Macy Foundation. It was a meeting in '98 about educating physicians and other healthcare providers, focusing on physicians though, about genetics. And since I'd been doing that in Vermont, and the guy who was the dean of the medical school at the University of Vermont, who knew me quite well, was on the board of the Macy Foundation. I think he's the one that said, hey, you ought to invite this guy Guttmacher. He's been trying to do something about this in Vermont. So I went to this meeting and I met there a woman named Kathy Hudson. So I said to Kathy, as I got to know her over the course of those 2 days or whatever, I've been meaning to talk to Francis because I knew Francis Collins from having done some research with him, that I'd love to come down to the NHGRI for 4 or 5 days if I could, sort of look over your shoulders, look at what you're trying to do in terms of integrating genetics into healthcare, and see whether we couldn't use Vermont, which has a fairly closed medical system, as a statewide model for doing that. That's kind of like what I like to do with the rest of my career. So Kathy corresponded with Francis by email, got back to me. Francis would love to meet with me to talk about that. Well, the next day, I and Kathy, for that matter, were going to Denver for the annual meeting of the American Society of Human Genetics. And we arranged for Francis and I to have breakfast together. So I was talking to Francis. I thought about coming down to NHGRI for a week, if that would be okay, to just sort of hang around and see what they're talking about these things. And over the course of that conversation, Francis said a couple things. One was, well, that's really interesting, but to be honest, we haven't really thought about that yet. And two is that he was aware that as the only MD in the non-intramural part of the program, he was often having to spend time doing certain things that only an MD could do, had the credentials to do, that weren't really appropriate for a director of an institute to be spending time on. So he said, well, gee, could you come down? Could we hire you on some kind of a mechanism, which I didn't understand, but I do in retrospect know what he's talking about, where they could hire me for something like a week, a month to come down over a year or two to the Genome Institute. And I said, well, the problem is I'm the only medical geneticist in Vermont, Francis. What happens if a kid gets born on one of those with, some kind of genetic or birth defect issue during one of those weeks when I'm in Washington? That won't work. So during the course of the breakfast, it sort of went to, well, maybe, well, how about if we just hire you full time, since we're not really thinking about these things yet at the Genome? Would you be interested in thinking about them for the country instead of just for Vermont? So I said, well, yeah, that sounds kind of interesting. I went back, and it's a long story. I won't bore you with, talked to my wife, et cetera, et cetera. And then they ended up creating this position. And it turned out, of course, had to be competed. So I put an application in and was selected to come down and be the senior clinical advisor to the director.
What were some of the consequences of medical geneticists focusing on single gene disorders?
And what's really, I think, fascinating, and this is among the many things where Francis and I had a similar view of the world, folks who are formally trained as medical geneticists, certainly back then, it's gotten much better, were schooled in and unfortunately only interested in single gene Mendelian disorders. So saw lots of kids with Marfan syndrome. It depended upon the setting, or chromosomal disorders, kids with Down syndrome, for instance, kids with Turner syndrome, kids with neurofibromatosis, et cetera. We often also began to see adults with those things as well. But there wasn't much attention at all played to the idea of, forget single gene disorders, what is the role of the genome in health and disease? And the American College of Medical Genetics and its members was slow, I think, at pivoting to that. So what's happened with many medical geneticists is they were sort of pigeonholed by themselves or by others as dealing with these relatively rare disorders. And you could argue Vermont had a population in those days of about 600,000 people, that maybe one medical geneticist and a couple of genetic counselors was kind of appropriate for meeting that single gene disorder kind of need. And I think part of my interest of how you integrate genomics into a healthcare situation system was realizing that there were unlikely to be 10 medical geneticists in the state of Vermont, was how was one going to educate and utilize a pretty darn good primary care, diverse medical healthcare workforce? How are you going to use them to integrate genomics into everyday healthcare, rather than, because I never thought that there would be enough medical geneticists or genetic counselors to see everyone in whom genomics would be useful to healthcare, since presumably that's all of us. That if you just do the math of I can't remember, something like 700 board certified medical geneticists in those days, and maybe twice as many genetic counselors, if you divide a couple of thousand people into a potential patient pool of 300 million people, you don't get to sleep much.
How aware was Francis Collins of this emphasis?
When we had that first discussion over breakfast in Denver at the ASHG, this was something that he was keenly aware of the potential importance of, and also that was part of NHGRI's mandate as it began to, finish the Human Genome Project. If one was going to think about a post-HGP existence for NHGRI, much of it was going to be about how do you broaden this tool so it applies both to research but also to health.
What were some of your first duties at NHGRI?
When I first got to NHGRI, it was really like having a fantastic sabbatical. I had come from doing, genetics on the ground floor, and suddenly, this analogy is quite, I'm suddenly playing right field for the Yankees or something, So I was, I started getting familiar with NHGRI and NIH, which I knew virtually nothing about, and also began to think these great thoughts. Now, shortly after I arrived here, I think within a couple of weeks, there still is this in different form, but the NIH Clips service, where every morning somebody sends around. So one morning there was a piece from the Wall Street Journal, which I must say otherwise I would never look at or read, that the New England Journal was about to get a new editor named Jeffrey Drazen. And it discussed what was Jeffrey Drazen going to do with the New England Journal. And the one content area he spoke most about was genetics. And I'm not even sure he used the term genomics. He might have. I think it was about genetics and how that was going to really be so much of the future of medicine. So I said, gee, that's interesting. So I went to Francis's office and said, have you seen this? Drazen was really interested in this. Maybe we can do something with the New England Journal once he gets on board or something. So Francis said, that's interesting. Let's think about it. So then when a couple of months later, or maybe less than that actually, when Drazen did become the editor, his first sounding board, or sort of op-ed piece in the, or not op-ed, but ed piece in the New England Journal was what he would do with the magazine, with the journal. And again, except in more detail, genetics was front and center. So I went to Francis's office. I said, have you seen this? He said, yeah, I saw that. We should, forget waiting for a few months to contact. Let's contact him and see what could we do. And I said, well, remember, at that point, I think it was 4 or 5 years earlier, they had a series in the New England Journal of Molecular Medicine. I said, why don't we approach them that they ought to do a similar kind of series on genomic medicine, and that we'd offer to help in any way, whatever. He said, it's a great idea. How much draft up a letter? So I drafted up a letter. Francis, I'm sure rewrote it, took away any split infinitives or the use of impact as a verb. It's a verb floating around here. So we sent it off to Jeff Drazen. This was my first lesson, I think, in the power of NIH and Francis. So we sent this letter to this new editor at the New England Journal saying, sometime we'd like to talk to you. Now, I'm still have my University of Vermont mentality. I figured in 3 or 4 months, we'll get back a very nice letter on New England Journal of Medicine stationery with a nice stamped signature saying, thank you for this idea. I've passed it on to our editorial group for further discussion. Instead, 3 or 4 days later, there's a phone call at NHGRI. The secretary from the front desk comes in and says, there's some guy looking for Francis or you, because Francis and I had co-signed this letter. And Francis isn't in the office. Would you be willing to talk to him? His name is Jeffrey Drazen. So I say, okay. So here I am. The editor of the New England Journal of Medicine has called to talk to the SCAD, though I don't think he knew I was, I don't know, he probably had no idea who I was, and saying he was going to be down at NIH the following week for some meeting, and he'd like to spend the afternoon meeting with Francis and me to go over exactly. He thinks this is a great idea. He'd want to sketch out the series with us, et cetera. So I checked Francis's calendar. Francis is unfortunately not available that day. And Drazen says, that's okay, I'll just meet with you then. So I go back to Francis, tell him this, and Francis and I sketch out together what this might look like. So I'm prepared for my meeting. So my little cubbyhole of an office down the hallway from where we're sitting now. Jeff Drazen comes, spends the afternoon, and we sketch out this 10 or 11 part series in the New England Journal of Medicine that he wants Francis and I to co-edit. So we agreed to do that. And so this was about this particular point in time, having Francis involved, which gave it the legitimacy. But as the SCAD, that became in some ways one of my biggest jobs to start with, was figuring out who our author should be, editing all of the manuscripts, et cetera, and coming up with this series on genomic medicine, which I think did have some impact. But again, if I was someplace else, I would never have had the opportunity to participate in that, let alone be one of the leaders of it.
Can you give us a sense of Kathy Hudson's work while you were at the NHGRI?
When I came to Genome, she did had an office here, but she was also one of the several people around the Institute who was a real confidant and intellectual partner with Francis, and got involved. There were clearly a lot of policy issues involving genomics in those days, and neither NHGRI nor Francis nor Kathy were shy about being involved in those things, looked for opportunities, didn't avoid them. So she played a large role here in doing that, and then of course left NHGRI to start an NGO involved in the same issues kind of thing, and which I think was good preparation for for the job that she has currently as a deputy director of NIH kind of thing. Somebody who's really schooled in the hard science of this, but also has, become a really self-taught expert in the ethical, legal, social implications, et cetera.
What was the significance of the difference in approaches between Celera and the public project?
I think it really is the basic driver of the disagreement between NHGRI and the Genome Project and Celera. Really, one can negotiate other things, perhaps, including credit for sequencing, et cetera, has happened. But it was kind of hard to negotiate the question of who is going to own genes. And again, if you thought about the Human Genome Project not just as sequencing, but as providing a tool that could be used to benefit humanity, having such a tool potentially locked away in a kind of restrictive closet really didn't make sense and made the whole reason for doing the project almost nonsensical. So I certainly drank the NHGRI and others Kool-Aid that as much as is possible, one wanted to make this knowledge something that was broadly available.
What was the major impact of the Human Genome Project?
I would argue that the major impact on science of the Human Genome Project is not the human genome sequence, but it is, and it wasn't the only contribution to this, but a large contribution. And it wasn't just in science, in this whole age of Wikipedia and broad access and ownership of knowledge. I think the primary contribution of the Human Genome Project was the idea that fundamental knowledge should be broadly and quickly shared and not owned by a principal investigator, not owned by somebody else, but owned by society.
What are some of the legacies of the Human Genome Project?
I do think that the Genome Project, because of its visibility, because of how broadly genomics as a tool is being used now, that part of what's happened is that this sort of genome cultural belief that information is to share has had huge impact.
How did studies of gene and environmental interaction become priorities in the early 2000s?
It goes back to the, sort of the foundational formula was G times E equals P. The genotype combined with environment gives phenotype, which is a really technical way, obviously, of saying that your biological makeup combined with the environmental influences that we're all subject to lead to our lives. So I think, again, Francis was not the only person, but he was certainly the driving force behind this and intellectually probably the most important contributor to it. The idea that if we were ever really going to understand that equation, which in some ways is the basic question of all of medicine, at least, if not larger part of life, that you would need some large study where you longitudinally followed lots of folks, characterized them very deeply in terms of genetic makeup, but also tried to characterize their environmental exposure as well as you could and phenotype them in an incredibly rich way. And that to really figure out these G by E interactions, you're going to have a whole lot of people involved to be able to begin to figure those out. It was going to take quite a while to do that, and that you wanted to start even before you had all the requisite tools to do it optimally. Francis is not the only person, but one of the things he's stressed over the years was don't let the perfect be the enemy of the good. And I think he's been good about reading the horizon, and seeing this is coming and knowing that the Brits were thinking about doing something like this same time, et cetera. I think both gave one belief that this is not a crackpot idea. Others are also thinking of it, but also wanting to have one really studying some of the complexity of life in the United States in terms of environmental influence, et cetera, is different from what you would see in the UK, for instance. And also making sure, again, that the data were made available widely so that everyone could utilize them in research. It seemed to be making sense back then that that would be a logical thing to do scientifically, and also that it was a logical thing for the NHGRI to have a prominent role in because of its both knowledge of sequencing, but also I think because of the ELSI program having been an integral part of it for a number of years by then, because there clearly would be, not just in terms of consent, but in terms of use of this information, some large ethical, legal, and social issues.
What are some of the immediate consequences of completing the sequence in 2003?
So that does lead to the large population studies. It does lead to HapMap. It does lead to the microbiome. It leads to GWAS studies. It leads to some of the drug discovery work that Chris and others are doing, et cetera. It was really saying, great, we've helped invent this tool. We know this tool better than anyone else, probably. A, that's a responsibility, but B, if we've invented this tool, we have some responsibility just for seeing that it's used for good. So let's go do that. And there were multiple uses for the tool, and some obviously still being invented. But it was a really rich, wonderful time, I think, of sort of intellectual ferment around here.
What were some lessons learned from the American Gene Environment Study?
I think part of it is that it is certainly valuable, if not invaluable, to have really creative thinkers, who cares who they work for kind of thing, helping shape this together, who are sort of state of the art in what they're thinking of and very much future thinking. That to launch any effort like AGES, it needs to be designed in a way that takes into consideration the fact that the design is going to have to change, that whatever design you come up with either isn't going to work, but even if it works, is going to quickly become outdated. So you need to design it in a dynamic kind of way that you don't have those moments later where you just sort of slap your forehead and said, oh my gosh, we forgot about blank. So that you would need, even if you didn't understand exactly what epigenetics was going to be, you need to think about the fact that it's going to be something someday, that modes of sequencing were going to change, that one would hope that modes of eliciting environmental exposures were going to change, et cetera, et cetera. And you have to be fairly ambitious with these things. And also why you need to be aware as a federal project of what the budget is, that it's first and foremost, this is the major thing I think I've learned by working with Francis. This seems to come across as some kind of pain to Francis, but at the end of the day, it's all about the science. And you have to focus on the science. And the rest, find the financing for it, all this, that's just commentary that comes after. You need to design the best science possible. Then you worry about how do you create the vision, how do you sell that vision to people, how do you get others on board with it, et cetera. But first you have to create a sharp scientific vision, and that means having really good minds together doing that.
What was it like being the deputy director of the NHGRI?
So the deputy director position is the most varied position at NIH. There are no two deputy directors at NIH who have the same job. And I doubt that there are even any two deputy directors of the same institute in sequence that have had the same job. My job was very different from Elka Jordan's. As the deputy director, you do duties as assigned, and often lots of duties as unassigned. You just do whatever needs to be done around the place, whether that's sitting at the table and registering people at some meeting because we're shorthanded, to representing the institute at a congressional hearing or something. You just do lots of different things. I think that what I saw here, and I'm sure others saw this too, was that I had something to contribute to the life of the Institute, but there were many areas that there were much more expert people than I. So I didn't see my role as managing Mark or managing Eric, certainly in the intramural program, but being sort of a liaison to come up with ideas of what might be useful to do those sort of affairs of state where you need to have the director or the deputy director present, smiling and signing things or whatever kinds of things. So my first job in some ways was to alleviate some of the more routine parts of administration from Francis. The second thing was this to be this honest broker to Francis, to be able to say, that's a crazy idea. What are you thinking? And part of it was to make, we spent some energy on trying to get the somewhat disparate part of the institutes all working together. And there were various sort of strains to that. But I think one of the things that we actually, Mark became the DER chief, Eric became the scientific director, I became the deputy director, all within a fairly short time span. And I think we had this mutual respect and affection.
How does intramural science contribute to the NHGRI mission?
If you're an institute director or a deputy director, you really tend to look at the institute as a combination of extramural and intramural, and you have this job to do, the institute mission. And they're kind of complementary pieces. There are some things which go better in an intramural environment. There's some things that go better in an extramural environment. There's some things that can go very well in either. And you see them as kind of complementary pieces to help achieve the overall mission of the institute. As you do with the third part of the institute, the Office of the Director, and you use the different pieces in ways they're particularly helpful. And you try to make sure that those pieces remain focused on that part they do best. So that, for instance, people say, but it's true, that in the current funding climate, et cetera, intramural scientists are better situated to do high risk, high reward research. They can afford to take the risks for various technical and other reasons more than can an extramural scientist in general. There's certainly exceptions to that. So you want the intramural program to do some of that more groundbreaking kind of stuff, so that, and you want to give people in the intramural program, as any scientist should have, the freedom to kind of follow their intellect and go to places that maybe aren't that obvious from their prior work. Kind of, you can see that you mentioned Les Sicker before. His work has clearly evolved over the time. He very much was a single gene geneticist when he started, but then really started looking at this question, well, gee, what happens if we actually got genome sequence on 1,000 people who think they're pretty healthy? What might we unmask there, kind of thing? That's the example, to me, of what an intramural program should do. And I think our intramural program arguably has done that. What Eric did at the sequencing center here to try to develop some new things. He wasn't the only sequencing center in the world doing that. Certainly what Chris Austin did within our intramural program at NHGRI when I was here, to develop this sort of chemical genomics kind of thing that almost nobody in academia was doing. It wasn't thought to be that worthwhile, et cetera, et cetera. But to state, well, gee, if this worked, maybe this could be really neat. To do that kind of stuff, that's what intramural programs should do.
What has been the significance of genome-wide association studies?
I've got a bunch of slides I used back then that tried to get this point across, and I wasn't alone in doing this. But many people, I think, misunderstood GWAS as being all about figuring out for an individual what variant did they have, and therefore what could we predict about their health risks. Yeah, it was going to be useful for that. And there, you need to have some real substantial effect size for it to be of much use. And I think in general, folks did overestimate what effect sizes we would find. But the fundamental reason for doing it, and where I think it has turned out to make the most contribution, the effect size almost didn't matter. As long as there was any effect, it was understanding specific genes' involvement in specific diseases to help you figure out the biological pathways of causation of disease that we'd never been able to do before. And I think changing the fundamental view of so many diseases from a symptom-based one to a biological pathway of causation-based one. so that if somebody comes in with asthma, you're unsatisfied eventually. It's just saying this is asthma. All that's saying is you're wheezing. Well, that's why they came to you to begin with. You haven't added anything. You've just come up with a somewhat more erudite name, or maybe say it was reactive airway disease if you're it's not. But what's the biological pathway of this? Is it due to, is it cold induced? Is it something else? Or is there a specific genetic pathway involved here? And is there some particular environmental perturbagen that works with that genetic risk factor to trigger this, et cetera, et cetera? And that's, to me, what GWAS was really fundamentally about. And I think that's where it's had at least some pretty good returns. I think the other thing it did was, again, it kind of bringing into the genomics realm some other kinds of scientists, and both integrating them into the genomics realm, but also integrating genomics into them, I think was another real benefit of doing that.
Has a better understanding of genetic variation led to better discussions of genetic risk?
Well, yeah, I think it depends upon the patient, how you would discuss risk, et cetera, et cetera. I mean, in some ways it's completely novel. Obviously, in some ways it isn't. It's why, people keep saying, well, gee, we've always done personalized medical care. What's different about this? Well, to some degree we have, to some degree we haven't. But it's true, every patient encounter is a unique one. And that's because of what the patient brings to it, what the provider does, et cetera, et cetera. And that includes what information you have available. Yeah, I think that folks are now more sophisticated about what variants mean and what they don't mean. So ideally, yeah, that's part of the conversation. Part of the challenge, of course, is how do you have that nuanced conversation with people who may not have the educational background? That's one of the things I think folks here at the Genome Institute cared about and try to see how can we broaden, the general knowledge about genetic factors. But then also, all kinds of other things the patient brings to bear about their level of understanding, but also what that particular variant means and how you do that within the tight time frame of clinical encounter is a challenge.
Why did you leave NHGRI?
I felt that there were other people, like Eric, for instance, better able to lead NHGRI to make sure it stayed true to continue to do some of the fundamental stuff. Yes, also involved in the clinical applications, but to make sure the fundamental science that only NHGRI could do was done well. That's important.
How did the newborn screening program at NHGRI and NICHD come about?
And this is something I think that NHGRI, for both the technical aspects and for the ELSI aspects, has legitimate ownership of. When I represented NHGRI out in the stump, but again, informed by my pediatric experience, my newborn screening, I was not alone, but part of, my stump speech was stuff about how one can see a day when newborn screening using current methods will be replaced by sequencing newborns. And it raises huge medical questions, huge ethical ones, et cetera, et cetera. We should start talking about that now because we're going to have the capability, follow the graph of, decay of cost of genome sequencing. This is going to happen. So it's pretty easy for me when I got to NICHD, which has historically been the place at NIH that's sort of owned newborn screening, to say, well, I just came from this place called the Genome Institute. Don't you think we should maybe get together over this? And Eric was keen to do it. And there were program staff who could see, Eric and I weren't the only ones, seeing the future. So it made sense, I think, to combine the resources in terms of staff, in terms of money, and also we bring to sort of different research communities to bear on this, to help figure out all the aspects. To me, there were always sort of three aspects of this to be figured out. One was a kind of methodological sequencing kind of thing, that sequencing that in other applications is okay because it has a small error rate. Well, that smaller error rate, if you can apply it to every newborn, one of the hallmarks of newborn screening is not having a whole lot of false positives. So how technically do you do that? That's a genome issue. How do you do that in a way that you're going to really beat down the false positive rate? Then there's the question of medical application of this knowledge. How do you apply that to kids' healthcare kind of thing? And that to me was kind of a shared, mostly in terms of background, that was NICHD, but also NHGRI kind of role. And the third thing were the huge ethical implications of this, which NICHD had a little bit of experience with, was primarily an NHGRI-LC kind of thing. So it just seemed natural that the two institutes would kind of come together and try to do this together. Makes sense, I think. I mean, it's the next, one of the things I point that a number of us used to make, back 10 years ago or whatever, when genomic testing was new and everything, as was genetic testing, even we'd say, well, almost everybody in this room, if you're under the age of 40, you've had genetic testing. It's called newborn screening. We do genetic testing for 4 million kids every year in the United States. It's called newborn screening. Light bulbs went over people's heads. Yeah, you're testing for genetic variation. You're just not it's not focused on the gene when you do it.
What is the leadership role of the NIH in American science?
Yeah, I think it's hard to overestimate the leadership role of NIH. And it's most often said it's because of our money. And that certainly helps. Yeah. But it's not all about the money. A lot of it's simply the bully pulpit, the focus we can provide, the role of being the catalyst, et cetera, the role of the convener. I had my first lesson in the power of NIH was when I came to NICHD, even before the New England Journal, I believe. So this was 99, and Francis, within, I think, the same week, had two different leading NGOs contact him. They were creating the genetics presence on the web, and they wanted to come talk to him about that. And because I was kind of involved in this, they met with both of us. So after the second of these, and when I think a third group had contacted him, we sort of had this conversation, you might want to have multiple genetics presences on the web, but there can't be more than one V. Why don't we get them all together in a room and invite all the other groups we think might be thinking about this? So maybe we can somehow create this common entity. If not that, at least these are all well-meaning, good organizations. The worst case scenario is there'll be a bunch of dogs sniffing each other out, and they'll at least know what everyone else is up to, save them months of work of trying to figure out whatever. So let's have a meeting that we'll call Genetics Resources on the Web. So here was my lesson. We sent out a letter in July about a meeting in August on a specific date, paying absolutely nobody's way to come, saying we want the head of your organization. We don't just want this delegated to somebody else. And we invited 26 organizations to come to the NIH for a one-day meeting. Not many of them were centered in Washington, but not all. So I thought, and Francis did too, we had this conversation, well, we're going to invite 26. It's only 6 weeks away. People are going to be vacation, whatever. They're not going to be worth it to come to this. Of the 26 we invite, we'll probably get maybe 12 to 15, and that'll be the right size meeting to really hammer this out every day. Well, of the 26 we invited, 27 came. One of the 26 said no. Their CEO was on a long planned family vacation, could not come. Two organizations that we hadn't thought to invite just sort of heard rumors that this was going to occur and begged, please, can you include us? And so this was at a cost of, because in those days we did serve coffee when people came to me, so it probably cost us $250 or something. We got these, 27 organizations to get together. They formed a group that for a while I think was quite useful until the web kind of matured. And it was this power of the convener. It wasn't because of our money. It was because NIH was seen as honest brokers, NIH was seen as having expertise, et cetera. You could bring all these different groups together to work on something together. And that happens over and over again. So I think the power of the convener, the power of being a catalyst, the power of spotlighting certain things, and yes, money helps. But it plays a really, I think, hugely important role in being the spokesperson to some degree for a large part of American science.
How did you become NICHD director?
Susan Shuren, who was a pediatrician, was a deputy director of NHLBI. She had been made by Francis the acting director of NICHD. But then Betsy Nabel, the NHLBI director, 3 weeks later, said, I'm leaving NIH. I'm going to head the Brigham in Boston. So suddenly, now Susan Shuren had to go back to be the acting director of NHLBI, which meant There was nobody to be the acting director at NICHD. So what was Francis going to do? Well, there was this other pediatrician around who he trusted, Guttmacher, but he was busy being the acting director of NHRI. You can't be the acting director of two different institutes at the same time, which is why Susan. So he knew by then that Eric was a selection, but was waiting, as you do, for the announcement of an institute director until it's been blessed by the Department of Health and Human Services. So they tried to expedite Eric's okay downtown, which they were able to do, so they could then offer me the position of acting director of NICHD, since I had said I wanted to do an NICHD. It's focused on child health and reproductive health. So it was a good fit for me for at least a while. And I did that for, I said, no, it's really kind of an interesting institute. I'll put my hat in the ring to be the director here. So that, in a nutshell, was my completely unplanned, as all steps in my career path have been, career path.